Welcome back. This is the second lesson recording for IM2, October 15th, 2020. So from the previous example, we've just established that this smaller triangle at the top and this larger triangle outside, they are similar. How are they similar? By angle similarity. Okay, so you have one pair of angles that are congruent and another pair of angles that are corresponding and congruent. So by angle similarity, they are similar. Okay, and if that is the case, then we know that this ratio, okay, to this ratio, however long that is going to be same as whatever this ratio is to this length. Okay, so because once the two triangles are similar, we've established that then we know that the corresponding sides are going to be proportional. Okay, what's also interesting is that there is yet another ratio that is proportional. Okay, so and it turns out if you have that side sk, the dotted red line, and ms, the length, if you put that as a ratio, so k, alright, so if I just write this down, okay, okay, this is really telling me that ks, where is ks? This length here is ks, to this length, to sm, is going to be same as this length divided by this length here. So this is very easily provable algebraically. If you want to see the proof of it, you can come see me after the class, but you can just take it by faith. So that this length here divided by this length is going to be same as this length divided by this length. Or likewise, you can say the solid line divided by dotted line is going to have the same ratio as the solid pink line divided by dotted pink line. Okay, alright, so then I want you to do some problems now. We are going to see if they are similar or not. So please copy this down and see if you can figure out if they are similar or not, and I'm going to go through the answers together. Here we go. Okay, so given this, what do we know for sure? Well, we know that this angle is common to both. So we know that this angle is common to this triangle inside as well as the triangle outside. We're talking about the green triangle inside and the orange triangle outside. Okay, so when I think about this, what do I know? I know that corresponding angles, the vertices, it's a common angle for both triangles. That means it's going to be congruent. So we know that we already have an angle. That means we don't have to check all three sides to be proportional. We can just check the two adjacent sides from the angle. So which is 54 here and 46 here, and 84 here corresponds to this length here. Okay, so let's set this up. So of the green triangle, the length, this length is 54. Okay, of the orange triangle, the corresponding side is really 46 plus 54. Okay, and that is equal to, of the green triangle, this length is just 84, and the orange side is 71 plus 84. Okay, so then we need to make sure, are they the same? Is the ratio the same? So you can certainly use the calculator and figure that out. So when I use the calculator, this is what I get. I get 0.54 for the left ratio and I get 0.541935 dot 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 for the right ratio. Are they equal? Well, they're very close, aren't they? But are they equal? No, they're not equal. They're not equal. So the ratios are not the same. So they are not similar. It needs to be exactly the same. Very close is not good enough. It's just being off by 0.001935. It's not good enough. This was 0.54 exactly. This was some, it goes on forever. Okay? All right, let's try the next problem. Okay? So are the two triangles similar? Do we know that they are similar? Well, what do we know? We know that the two vertical angles are always going to be congruent. So we have angle pair that is exactly the same. Okay? Do we know anything else? Well, we're told that this line FE is parallel to BA. That means, what do we know about this angle and this angle? Okay? What are they called? They're alternate. So they are alternate interior angles of parallel lines. And we know that they are always going to be congruent. So I know that these two angles are congruent. That means looking at this top triangle and the second bottom triangle, we have two pairs of angle correspondence, corresponding angles that are congruent. That means by angle similarity, the two triangles are congruent, not congruent, similar. So that means we need to match them up. Okay, so what is my similarity statement? Well, I need to start with triangle. Let's start with D. That's the easy one. And let's go with F, and that E is similar to triangle. D is common to both. Now, we need to match up F. What does F match up with? Does it match up with B, or does that match up with A? Well, we know that this angle measure and this angle measure are exactly the same. They are congruent. So that means F and A match up. So that's going to be A. And then finally, it's going to be DAB. So that's my similarity statement. Okay, so let's look at this some application of similar triangles. Squawking chicken. This is a CPM problem. It's a legend has it that if you look into a person's eye in a special way, you can hypnotize them into squawking like a chicken. So place a mirror on the floor. Your subject has to stand exactly 200 centimeters away from the mirror and stare onto it. You need to figure out where you have to stand so that when you stare into the mirror, you're also staring into your subject's eye. Then your subject will squawk like a chicken. And let's see this in action. So here we go. Yes, that was me and Mr. Liu, another IM2 teacher, being filmed by Miss Chu, another IM2 teacher. That's what happens when you put math teachers together. Okay, so squawking chicken. Let's see if we can figure out the similar triangles here. All right. So the first thing you need to do is draw diagrams of the situation. And where are the two triangles? Where are the two similar triangles? Well, the two triangles are similar because of AA similarity. Where are the two pairs of congruent angles? Can you figure them out? Well, it so turns out that there is a mirror right there. And the property of light says that light reflecting straight reflects at an exact same angle Okay, so right heading into the mirror at an angle will reflect at the same angle. Okay, so this angle and this angle is going to be the same. So which means this angle and this angle is also going to be the same. So you have, there is a vertical line here, this angle and the other angle, the two blue angles are congruent, or they're the same, and you know that each of what both are myself and Mr. Liu, we are all standing vertical, so that's another angle that we know that are congruent and corresponding. So it is by a similarity that this triangle on the left and triangle on the right are similar. And how far is the mirror to Mr. Liu? Is 200 centimeters, because that's what the legend said. And we need to figure out this distance. Okay, but we do know to calculate it, what additional information is needed. We need to know how tall, where my eye level was, okay, as well as where Mr. Liu's eye level was. So it turns out when we measured from my eyes all the way down, it turned out to be like 150. And then when we measure Mr. Liu's height, where he is at, and that turned out to be approximately 195. Okay, all right, so then we know that Mr. Liu's eye level height was 195 and my eye level height was 150 centimeters. So what should D be? So we need to figure out what D is, do the calculation. So since we know that two triangles are similar, we can set up the ratios. Okay, so I know that 195 and 150 would match up, and 200 and D would match up. But also another way of looking at it is the ratio between 195 and 200 is also going to be the same as 150 to D as well. So I can use that as well and say D over 150 is going to be same as 200 over 195. Then you cross multiply and solve, and you get D to be about 154. And when we actually measured it, here we go. It turned out to be approximately 147, I think. Okay, so here you go. Okay, so using similarity to find missing sides. Well, application problems, you have, do I know if they are similar? That's the first question you need to be asking yourself. And then if I know the shapes are similar, then how can I figure out the measurement? So it depends on what you know and what you're trying to do. So if two shapes are similar, then I know that all corresponding angles are equal in measures and all corresponding sides are proportional. So likewise for this polygon, we know, if we know that these two polygons are similar and we're given that by this similarity statement, then we know that corresponding sides are going to be proportional and the corresponding angles are going to be congruent. So what do we know about measure of V, measure of U? Well, V corresponds to C. Angle V corresponds to angle C, because V is the second to last letter and C is the second to last letter in that similarity statement. Okay, so that must be 70 degrees. What else do we know? V and U are same side interior angles, so they must at 280 degrees.